Academy. For today, we're looking at a complex example on integration by parts involving perhaps exponential and trig functions combined. But before then, let's note these things. Number one, if I integrate cos x, I will have sine x. Also note that if I integrate sine x, I will have minus cos x. Alright, like note these two. Alright, so we use these two in doing some solvings. Also note this, if I'm having to integrate sine, let's say 3x per se, or should we use sine 3x, the x. For this case now, I'll have to use substitution method, such that for this I'll say let u be equal to 3x, such that du over dx is equal to 3, and hence I'll have that dx is equal to du all over 3, such that from here I'll have that the integral of sine, so having sine 3x, we said 3x is u, so in place of 3x I'll put u dot dx is du over 3, so it becomes du over 3 on substitution. My constant term here becomes 1 all over 3. So take 1 over 3 outside the integral sign, becomes 1 all over 3 integral of sine u du. So this now gives equal to 1 over 3 sine. If I integrate, 1 over 3, if I integrate sine u, I'll have minus cos. Alright, when I integrated sine x, I had minus cos x. Similarly, if I integrate sine u, I'll have minus cos u plus perhaps c. This will now be equal to minus 1 over 3 cos u. But we said u should be equal to 3x. This is now equal to minus 1 over 3 cos u is 3x, this plus c. So we have this as the answer after integration. We could choose to multiply this. Minus 1 times cos 3x gives you minus cos 3x all over 3 and plus c if you want to. So the idea is now this. The idea is this. The idea now is this. If I'm asked to integrate sine ax, this will be equal to minus cos ax all over a. That's like a shortcut. Also, if I'm asked to integrate cos ax with respect to the x, this will give you sine ax all over a. So please note these things. Note that if I integrate cos x, I'll have sine x. If I integrate sine x, I'll have minus cos x. If I'm integrating sine ax, where a is a constant term, it gives minus cos this all over a. If I integrate cos a constant term and x, it gives sine this all over a. So one quick example. If I integrate cos, let's say 8x, this will now be equal to sine. Alright, so it becomes integrate cos, get sine. Repeat this one here, ax. What I have here is 8x all over. Differentiate ax, you get 8. Differentiate 8x, you get 8. So I have this as my answer. Alright, so let's see how we can apply the shortcut into solving complex problems on integration by parts. So let's say I'm asked to integrate exponential 2x sine 3x dx. In this case, observe that the value of the two given values, that's exponential and trig functions, we are both the same. When it comes to these two values, assume both of them to be dv. Alright, so this was the case we considered to be dv, and also trig function, that's sine. So we said you should consider these two as dv. So in this case now, it's not proper to consider these two values as dv. So what we have to do is this: we'll take one of them as u, and take the other one as dv. So for this, I will take u as exponential 2x. So I will say let u be equal to what I have here, exponential 2x. Next up, I'll have to differentiate this. If I differentiate u, I'll have du such that du, using the shortcut method of differentiation, if I differentiate exponential 2x, I will get 2 exponential 2x. Next up, I will say let dv be equal to what I have here, sine 3x. Also, using the idea already explained for this, we said if I integrate this, I'll have minus cos 3x all over 3. So we've gotten our 4 values here. Substituting into my integration by parts formula, I'll have that the integral of u dv is equal to uv minus integral of v du. Alright, so this is now equal to, the value of u here is exponential 2x. So I have exponential 2x into v. The value of v here is this, that's minus cos 3x all over 3. So here is uv minus integral of v. The value of v here is minus cos 3x all over 3 into du. Du here is 2 exponential 2x. So I have this case. Alright, if I simplify this, this will now be equal to this times this, the minus goes off. So I'm having minus exponential 2x and then cos 3x, this all over 3. I'm having 3 there. From here I'm having minus the integral of the constant term here is 2 in the numerator and 3 in the denominator. So it becomes 2 all over 3. So minus here 2 over 3, 2 all over 3. I'm left with cos 3x and exponential 2x. So I'm left with cos 3x and exponential 2x. In the equation arrangement, observe that the value of the exponential function was taken before the value of the trig function. So in the same case now, I will take the value of the exponential function, that's exponential 2x first, before the value of the trig function, that's cos 3x. So I have this one here. Alright, so next up, take the constant term outside the integral sign. This becomes equal to minus exponential 2x cos 3x all over 3 minus is plus 2 over 3 into exponential 2x cos 3x. So I have this. So I'll pick this up now and integrate it by parts. So picking integral of exponential 2x cos 3x and integrate by parts. For this, for the integral of exponential 2x cos 3x, for this, obviously, u will be equal to what I have here, exponential 2x. Du will be equal to 2 exponential 2x. From here, dv will be equal to this value here, cos of 3x, and then finally v will be equal to cos gives you sine, so it becomes sine 3x all over 3 from our shortcut. So that would be sine 3x all over 3. Alright, so proceeding with this. So substituting this, I have it being equal to uv minus integral of v du. That's equal to u is exponential 2x here. It becomes exponential 2x into v. V is this sine 3x all over 3. So sine 3x all over 3 minus integral of v. V is sine 3x all over 3. Then du. Du here is 2 exponential 2x. So I have this. If I try to simplify this will now be equal to this, and this gives you exponential 2x sine 3x all over 3 minus my constant here is 2 all over 3. Take it outside the integral sign, it becomes 2 all over 3 integral. If I take out 2 over 3 here, I'm left with sine 3x and exponential 2x. So take the exponential function before the trig function. I have exponential 2x sine 3x. I have this. Alright, that means on evaluating the integral of exponential 2x cos 3x, I have this as my answer. So substitute perhaps. Let's call this asterisk. I'll call this equation asterisk. So substituting into equation asterisk. From equation asterisk, I had this. I have minus exponential 2x cos 3x all over 3 plus 2 over 3 into this. This value is what we got as this. So in place of the integral of exponential 2x cos 3x, I'll put in this whole value. That becomes this exponential 2x sine 3x all over 3 minus 2 over 3 into this integral of exponential 2x sine 3x sine 3x this, and I have this. Alright, so this is now what I have here. If I substitute this value, which is this, into the equation asterisk, I'm left with this. So next up, I'll have to expand all of this with this. So I'll expand all of these terms in the square bracket by 2 over 3. Okay, so recall that initially we are asked to evaluate the integral of exponential 2x sine 3x dx, which after our whole process we had this answer. We have minus exponential 2x cos 3x all over 3, okay, plus use this to multiply through. I'm having this to this. I have 2 exponential 2x sine 3x all over 3 times 3 is 9, plus times minus gives minus, 2 times 2 gives 4 all over 3 times 3 gives 9 integral of exponential 2x sine 3x. So I have this. Now observe that this question here is being repeated here. That means if I should pick this and evaluate it again via integration by parts, I will still come back to this whole process. So in this case, when you have the question itself being repeated, that means it's continuous and it has no answer. In that case, how do you solve this? What you do is this. You say, let I be equal to the integral of exponential 2x sine 3x. That means wherever I see integral of 2x sine 3x, I'll put I there. Hence, all of this is now I equal to, this is now I equal to minus exponential 2x cos 3x all over 3 plus 2 exponential 2x sine 3x all over 9 minus 4 over 9 integral exponential 2x sine 3x. We set this equal to I. It becomes 4 all over 9I. So I'll take this one off. So the case here will now be move this one here over here. That's collecting like that, or taking the i's together. I'll be having this one here. That's I minus 4 over 9 comes over the quantity sign, becomes plus 4 over 9I is equal to minus exponential 2x cos 3x all over 3 plus 2 exponential 2x sine 3x all over 9. Okay, so I've moved minus 4 over 9 over here, becomes plus 4 over 9. So I'll have to take off this one here. So the case here will now be move this one here over here. That's collecting like that, or taking the i's together. I'll be having this one here. That's I minus 4 over 9 comes over the quantity sign, becomes plus 4 over 9I is equal to minus exponential 2x cos 3x all over 3 plus 2 exponential 2x sine 3x all over 9. Okay, so I've moved minus 4 over 9 over here, becomes plus 4 over 9. So I'll have to take off this one here. So 1 plus 4 over 9, 1 that's I plus 4 over 9I will be equal to, take coefficient. The coefficient of I here is 1. So 1 plus 4 over 9 gives 13 over 9. I'm having 13 over 9I is now equal to all of this minus exponential 2x cos 3x all over 3 plus 2 exponential 2x sine 3x all over 9. So I have this. Alright, so if I want to get I here, it's simply multiplying. If I multiply I by 9 over 13, I'll get I standing alone. So I have 13 over 9I. Simply multiply this value by the inverse 9 over 13. So that 9 cancels 9 and 13 cancels 13. I'm left with I. So multiply both sides by 9 over 13. If I multiply this by 9 over 13, I'm left with I being equal to, multiply this by 9 over 13. I have 9 over 13. Multiplying all of these, that's minus exponential 2x cos 3x all over 3 plus 2 exponential 2x sine 3x all over 9. So if I multiply this now, first of all, take this one off. Okay, so I have this, but we said that I is equal to the integral of exponential 2x sine 3x. This of dx. So hence I now have that the integral of exponential 2x sine 3x dx is now equal to all of this. That's 9 over 13 into minus exponential 2x cos 3x all over 3 plus 2 exponential 2x sine 3x all over 9. This, of course, plus c, which is the constant of integration. So this is the answer on integrating this. You could choose to expand all of this by 9 over 13 if you wish, but this is like the method or the process of solving integration by parts for questions like this. Alright, so this is the answer after the whole solving process, alright? So this becomes, you can choose to expand it if you want. That's use 9/13 to multiply through all of this if you want to expand, or you can still leave it this way. It's still correct. So this is what you get while expanding questions like this or solving questions like this.